Hey everyone, it's definitely been a while. I'm pretty sure last time I spoke to you guys in depth about anything was in regards to this right here. It is a fairly simple 2D turn-based strategy game where a bunch of skeletons just beat each other up. I say it's a game, but in reality it's pretty much just a single level, and I mainly made it to explore how these types of games are made. If you're interested in how I made it, I'll leave a link in the description below, or maybe in the card above. That being said, after I did complete this 2D game, I wanted to try making something in 3D instead. And instead of it being just a single level with some cool programming behind it, I wanted to make a full, complete game this time. Again, I'll be using Unity for this project, but all the programming and code is mostly general concepts. Please enjoy yourselves as I talk about coming up with an idea, programming it, and doing all the other miscellaneous stuff that comes with game development. I'll make sure to leave a link to the game in the description below if you want to go check that out. And full disclosure, we're not trying to imply anything with the game's title, it just seemed like a really funny premise. So, without further ado, let me go ahead and talk to you guys about that time that I got stuck making a game about a raccoon that clones itself in order to fulfill his sake addiction. Okay, before we can start making anything, we're going to need some direction. Every game has a hook of some sort, so I decided early on that this game's hook was going to be clones. Let's take a look at clones in a few other games to maybe draw some inspiration. In League of Legends, there's a few characters that can create clones. The one that stands out the most is Zed, a character that, well, creates clones. If Zed needs a clone, he can create one which lasts a few seconds. These clones aren't tangible, but they copy any abilities that the player uses. In addition, Zed can swap between the clones, which increases the character's complexity. Now let's take a look at Dota 2. Here's Meepo, a hero whose clones are literal copies of himself. Once he learns his ability, a clone of him is permanently spawned. And the cool thing about these clones is that they can all independently cast abilities, so you can do some crazy stuff like this. These clones are also tangible, so they can take damage and interact with the world as a normal hero. Let's take a look at some of the characteristics of the clones, and we'll choose a direction to work towards. Zed's clones are intangible, which I don't really like. However, I do like that Zed can create his clones whenever he needs them. On the other hand, Meepo's clones are tangible, which would lead to more interesting gameplay. However, I don't like how they're always active, as you're going to need to continually manage them. So ideally, I'm going to make a game with tangible clones, and you'll create them whenever you need them. I'm pretty good at MOBAs, but these heroes are honestly way too difficult for me to play. And that's mainly because in addition to knowing where your clones are, you have to play optimally and consider a lot of factors. And mind you that this is only in 2 dimensions, so if I were to implement clones in a game, I don't want to force the player to continually manage their clones, as it seems to be extremely complex, especially in a 3D environment. This makes me lean towards a more relaxing or a slow-paced game, maybe a puzzle platformer or something of that nature. So here's the plan. I'm going to make a 3D puzzle platformer where you can overcome obstacles. Hopefully we can make the game mechanics simple without compromising on the depth that we can get from this concept. Before we actually start programming anything, let's draft a rough idea on how the game can be made from this concept. Okay, we have a plan now. Let's go ahead and talk about our gameplay loop. Let's start by adding the player character as well as an endpoint. To complete a level, let's just say that the character has to reach the endpoint. Pretty simple, right? Walking in a straight line doesn't usually make for a difficult game, so let's go ahead and add an obstacle for our player. If we decide to add a raised ledge, it prevents the player from reaching the goal. So this is where our new mechanic comes into play. The player will use clones in order to overcome any obstacles that are presented to them. Let's go ahead and reset the scene. Let's say our player walks out and creates a clone. The control shifts over, and the clone then walks over to the ledge. Then we can go ahead and lock the inputs, and once the inputs are locked in, the control then returns to our original player. With the inputs recorded, the same actions will be played out, and our character can now reach the endpoint by jumping on his clone. Pretty neat, right? Before we jump into the code, let me explain to you the 2 systems that mesh together in order to make this game possible. The very first one is a replay system that I created For Unity, this was a couple months ago now, if I think about it. And to keep it short, all it does is that if the player inputs a key, it's going to record the time of the input. And then once the object needs to replay the inputs, it's going to go ahead and look at the timestamp, find the correct time, and then just play whatever was stored at that timestamp. If you want a more in-depth look at that, I will leave a card at the top right hand corner, or I'll put a video link in the description. Now let's go ahead and actually talk about the second system that we're going to be using here. Trying to understand the code in 3 dimensions is pretty difficult, so let's go ahead and simplify our scenario by going 2D. In our example, these circles will represent points in time, and the lines between them will represent transitions. First, let's draw a circle around our player's spawn point. He then walks forward and decides to create a clone. We then draw a circle here as well, as it's indicative of when a clone was created. I'm going to offset the clone's movement to make things a bit more clear. Our clone then moves towards the ledge and finalizes his position. At this point, we draw another circle to mark the endpoint. Control then jumps back to our main character, and then we can jump on top of our clone to finish the level. This is where we draw our final circle. Let's go ahead and remove the 3D portion of this, and what we're left with is this diagram. To most, this seems like a very simple diagram with our movements. However, if we flip this by 90 degrees, things may seem a bit more apparent. It's a tree. For those who don't know, a tree is a data structure that is a system of linked nodes. I'll go ahead and highlight the nodes in red. So what exactly are nodes? It's pretty much just a point of connection where we can store information. If you remember my brief explanation on the replay system, you'll recall that it has inputs and the timestamp for those inputs. But how does it actually know what the current time is? That's where the nodes come in. Let's say that this entire diagram is finished within 10 seconds. At the beginning, we have our first point at 0 seconds, then our character clones here around 3 seconds. This point is recorded by our node system. Our clone then moves towards his final destination and completes his path. At this point, we have recorded all the movement information for our clone, so when we return back to our clone's original point, we can start the playback at that timestamp. While the replay is running, we can then move our character in tandem with our clone, where we can finish the level in 10 seconds. Even with the diagram, it's a bit hard to fully grasp the concept, so let's take a look at what's under the hood and take a look at the code. Here, we have a bunch of nodes. Don't worry about the specifics, let's take a quick look at player node. There's the to, from, and split variables, which allow us to traverse back and forth between nodes. In addition, there is the time variable. This keeps track of when the node was created. We'll get back to this value later. Now, let's take a closer look at some of the code in the player. There is this add reset points function. You can see that this function saves data into a dictionary, with the key being a timestamp. There is also this function here called data reset, which takes a timestamp as its parameter. Whenever a change in time happens, the nodes will relay the time over to these functions, which will allow for the actors to properly reset. Let's see this in action. What you see here is an extremely early version of the game, which I recorded months ago. I might need to splice the footage a bit, but as you can see with the debug panels, each node contains the time of creation and what type of node it is. With the timer in the top left corner, you can see when a clone has finished his path, and time reverts to the previous split node. You might be wondering why I decided to use nodes in the first place. Well, it's because I think they're fairly easy to work with, and they're very easy to expand. If I want a new clone, all I need to do is make a new node in the network. And because everything should reset properly and just work as intended, I can go ahead and cascade one clone into many clones without any issues. Well, at this point in development, I've pretty much finished the main gameplay code, but that usually doesn't make for a finished game. However, if I talked about every single aspect that I worked on, we'd be stuck here for a while. So let's go ahead and show off a montage about everything that had to be done in order to finish the game. I'll make sure to leave any references and resources as I go along. Well, everyone, thanks for listening to me talk about developing a game for the last 10-20 minutes or so. This was a really fun project where I learned a lot of different skills. To me, the most important skills were probably the event systems and the delegates that went along with it. These allowed me to add a lot of different functionality to the game without breaking any of the existing code, so that was great. And the next thing was also something I left out of the video. It is creating custom editor tools in Unity. It's allowed me to streamline the game development process. Our game currently has 7 levels, 3 tutorial levels with 0 clones, and 4, World 1 levels that have 1 clone each in them. And this is all we have. Mainly this is due to time constraints. If I wanted to keep adding on levels, I could. However, most of these levels would be the default Pro Builder blocks, and they wouldn't have assets. And to me, that doesn't really seem like a finished game, so I decided against making any more levels after a certain point. If I had more time, I definitely would have loved to make even more levels so you could experience like 2 clones, 3 clones, so forth, to actually complete puzzles like that. I definitely would have loved to improve the movement code, maybe add a few more features as well, and I would have liked to add combat as well. However, for now, I'm going to leave it at 7 levels, and maybe if I have time in the future, I would go ahead and create new levels. I don't know about the assets, though, might have to reuse a few. So, before we move on to anything else, I really would like to thank everyone for 50 subscribers, 100, 150, 250, 500, and 750 subscribers. Honestly, each and every one of you means so much. I honestly wouldn't be making these videos without that number, so thank you so much. You guys are the reason why I made this game in the first place, and pretty much why I made this video to go along with it. I think that everyone who watches has at least some interest in game development, or maybe they like understanding the code behind it and stuff like that. So actually, now that I think about it, I can go ahead and make this project open source. It might take a while. So why don't we aim for a milestone? Let's say if we hit 1,000 subscribers and I have enough time, or I have enough time in general, I can go ahead and clean up the code and see what I can do to go ahead and put this to be open source. Then I'm pretty sure most of my viewers are fairly talented or have their own ideas for the game. So you guys can go ahead, grab the code, and just implement your new ideas. I can't wait to see what you guys can do if I ever put this to be open source. So thank you so much for that, everyone. And on that note, thanks for watching, everyone. Hopefully I've sparked your creativity to make your own game, or at least appreciate the work that goes into the game, no matter how small. Thank you, everyone. Have a good one. Later.